This is task 8.2 project teaching case for SIT210 embedded systems development, and my name is Satvik Sharma and my student ID is 2185959095. Okay, I created something like sanitech because a new virus started spreading in China in December 2019 and started slowly spreading to the whole earth. As it was spreading, the people started to panic and people started wearing face masks and using hand sanitizers continuously. So as you can see from the image, there were these many cases and these many deaths at the certain time of making this video. So, as to create a solution for people to go out freely in public and have access to hand sanitizer easily, I created Sanitech. So, this device uses single board computers which will allow the people to sanitize their hands without touching any bottle. This device can be placed in public places which will have two benefits. Number one, allow the people to roam with safety. Number two, maintaining hygiene. This is like a very important device that is needed to fight off the coronavirus. Sanitech is based on certain design principles. So the first one is design for safety. The prototype is designed so as to get safety from COVID-19 spread. Since the safety from virus is the most major concern, it will help protect the people who need to be outside and flatten the curve. Second is design for serviceability. The Sanitech is designed to provide service to people, which will lead to an increased hygiene and lower spread of the virus. It is easy to use and can even be used by toddlers. Design for simplicity. The design is very simple and I am going to teach you how it works so you can make it at home. Sanitech basically works in two phases. First one is to filling up the tank of the Sanitech with sanitizer, and second one is getting the sanitizer out of the sanitizer into the hands. So there is an ultrasonic sensor above the tank of the Sanitech, so which is going to sense the level of sanitizer inside, and when it is empty it will send a notification to the user on mobile phone and ask them to refill the tank again. And the second phase uses a motion sensor placed underneath the body and will use the motors and gears to squirt some hand sanitizer into the hand of the user. Functional requirements for Sanitech. This is just a prototype and we just want to test it out first, and our target is to get an IFTTT trigger with the blinking of LEDs. According to my model, I have assumed the depth of sanitizer tank to be 20 centimeters. Therefore, the model must trigger an IFTTT and give the mobile a notification when the sanitizer is finished or less than 20 centimeters in the tank. Another thing that it should do is when the motion is sensed with the Raspberry Pi, the LED on the Arduino should turn on, showing that when the motion is sensed, it communicates with another device and thus show the output as turning on of the LEDs. We'll be requiring certain hardwares to make the working model of the Sanitech. So what we are going to need is a Raspberry Pi, an Arduino Uno board, particle argon, LEDs, PIR motion sensor, ultrasonic distance sensor, male to male jumper wires, male to female jumper wires, female to female jumper wires, and a mobile phone to get a trigger from IFTTT. Along with the hardware, it also requires some software knowledge. It requires a number of software and background knowledge to create a working model, and it requires basic knowledge of programming to create this type of prototype. The number one is Raspbian. Raspberry Pi works on a Linux-based operating system, which is the Raspbian. Also, a little bit about the working of motion sensor in Python-based programming environment. Particle Web ID. This is used to create operate particle-based devices. This will be used to get data from the ultrasonic sensor and publish it via an IFTTT trigger. Arduino IDE. This will be used for programming Arduino Uno and work the data got from the Raspberry Pi and further use it to turn on the LED. IFTTT. It will be used to trigger notifications to mobile application. How to connect all the devices I have mentioned in the table. As you can see, and I'll be telling them through my audio as well. So the VCC motion sensor is connected to the pin number 2 on Raspberry Pi. The ground of the motion sensor is connected to pin number 6 of the Raspberry Pi. The S pin on the motion sensor is connected to the pin number 7 of the Raspberry Pi. Pin number 3 on the Raspberry Pi is connected to pin number A4 on Arduino Uno. Pin number 5 on Raspberry Pi is connected to pin number A5 on Arduino Uno. Pin number 7 is connected to ground on the analog side of Arduino. LED on Arduino is connected to ground, and number 13 on the digital side of the Arduino. LED for argon is connected to the pin number D7 and ground on particle argon. Ground on the ultrasonic distance sensor is connected to the ground on the particle of argon. Echo on ultrasonic distance sensor is connected to D5 on particle argon. Trig on ultrasonic distance sensor is connected to D4 on particle argon. The VCC on ultrasonic distance sensor is connected to a 5-volt pin on Arduino Uno. Now I will be explaining the system architecture. So the first thing that I'll be explaining is the PIR motion sensor. It senses the motion of the hand in the bottom of the hand sanitizer, and then gives some certain data to Raspberry Pi, which will then give which is then connected to Arduino Uno via an I2C, and will communicate to Arduino Uno. And then further, Arduino Uno will receive the data from Raspberry Pi and then turn on the motor system that squirts out a little hand sanitizer into the hands, or in my case it will turn on the LED. And the next thing is ultrasonic distance sensor, which is connected to a particle argon, and ultrasonic distance sensor will detect the distance between the hand sanitizer. If the hand sanitizer get finished, the particle argon will publish an IFTTT trigger, which will give a notification on the mobile phone via the IFTTT app. And if the hand sanitizer is not less than the mark, so it won't give anything. The one thing which I have depicted by ultrasonic distance sensor connected from Arduino Uno is that ultrasonic distance sensor works only when it gets 5 volts. So particle argon can just give 3.3 volts. So that is why I have connected the 5-volt pin from ultrasonic distance sensor to Arduino Uno. Now I'll be explaining my Raspberry Pi code. So the first line says that from GPIO0 import motion sensor. So there is a library known as GPIO0, and we are importing just the motion sensor so that the motion sensor starts working. The next library we are importing is SMB bus, which will help connect the Raspberry Pi with Arduino Uno, and will help the and will communicate between Raspberry Pi and Arduino Uno with an I2C communication. And then I'm giving the motion sensor a pin, which I have connected to pin number 4 on the Raspberry Pi. The next thing is I have written an address, which is also written in the Arduino Uno code, and this specifies the address to which it has to communicate with. And the next thing is I'm giving a variable for the SMB bus, and then I have made a while loop which will work unless it's true. And if the motion is detected and it's true, the LED on the Arduino Uno will start to light up. I've written code according to that, and then it will sleep, and then it will turn off again. Otherwise it will remain off. Now I'm going to explain the Arduino Uno code, and the first thing I have done is include a library which is wire.h, which will help it communicate with the Raspberry Pi. And then I have made a constant integer for the LED, which is plugged to the point to the 13th pin on the digital side. And in the void setup, I have written that wire starts to begin, and then I have written the address, which is 0x0 cross 8. And then if the wire receives an event, it will the starts to work the class I have made below it, and it will start to light up the LED, which will be initially low. And then I have made a class which is receive event, and in that class I have made while the wire is available, a while loop. For the wire is available, there would be a character that will read the wire, character variable which will read the wire, and then it will write that LED wire read. So basically it will turn on and off the wire according to the events that it has received. In the void loop, I have done nothing much. It's just a delay for 1 millisecond. Finally, I'm gonna talk about the particle argon code. So I have first thing I have done is include an hcsro4.h library, which is basically the library which helps the particle device to run the ultrasonic distance sensor. And then I have declared some variables which are plugged into the um, ultrasonic sensor. And then I have declared a range which will be calculated on the basis of trigger and echo that is that is sensed from the sensor. In the void setup, I have just declared the LED output, and in the loop I have created an if else. And first thing I have done is get the distance, and in the if else, if the distance is more than 20 centimeter, it will just show that it will just turn on the LED, and it will publish an event which will say that the sanitech tank is empty, so please fill it. And otherwise it will publish the event that it is full, no need to fill it, and it will just work after a delay of 1 second. Now I'm going to talk about the communication, how the communication occurs between the devices. The first one is the I2C communication, and which is between Raspberry Pi and Arduino Uno. The motion sensor detects the hand, and the Raspberry Pi then communicates with the Arduino Uno to pour some hand sanitizer into the hand of the person. And the second type of communication that I have used in my prototype is IFTTT trigger, which is between the particle argon and the mobile phone. And it is done with the help of IFTTT trigger, so it will send a notification on the phone when the tank is empty. Now I'll be showing how my device works, and hope that your device works the same as well. So on the left, this is just a demonstration uh, clip from my whole video. If you want to see the whole video, you can just use the link. And on the right is my IFTTT notification that the sanitech is empty, so please fill it. And that's it for my project. Thank you for watching. I hope you liked the video.